Hello everyone. In last class, we discussed about system attributes affecting the performance. So one was machine capability, and one was the program behavior, and how algorithms, data structures, the languages, compiler technology, and programmers' efficiency, how it affected the performance of a system. And in today's video, we are going to measure the performance of the CPU. And so we have some formulas for measuring the performance of the CPU. So here, uh, so if you observe here, essentially all computers are constructed using clocks. Okay, so clock, also called as ticks, clock ticks, clock periods, clocks, cycles, or clock cycles. So usually, whenever we say that it took 10 clock cycles or 10 clock periods, okay. So we are measuring also the clock rate at running at a constant rate. Now, clock rate is nothing but a frequency at which the computer is running. That is, nowadays, if you see any CPU's speed, it is in terms of 2.4 gigahertz. So usually it is measured in terms of hertz. Giga means 10 raised to 9, and clock cycle time. Uh, so is nothing but it is an reciprocal of clock rate. So you know the formula, it is time is nothing but 1 by f. So here frequency is nothing but clock rate. So by taking into clock rate and clock cycle time, we will get an equation called as CPU time for a program can be expressed in two ways. So first one is CPU time is equal to CPU clock cycles for a program into clock cycle time, or CPU time is equal to CPU clock cycles for a program divided by clock rate. So CPU time is nothing but CPU clock cycles for a program into clock cycle time. Suppose think that if there are 10 instructions in a program and each instruction takes certain time. Okay, so think that it will take 1 nanosecond. Okay, 1 nanosecond. Okay, and if I want to find the CPU time for that program, so program consists of 10 instructions, each instruction takes 1 nanoseconds, then CPU time is nothing but CPU clock cycles for a program into clock cycle times. Okay, so we'll understand these formulas when we solve certain problems. So usually I'm giving certain hints that usually CPU time is measured in terms of seconds. Okay, so how much time it took to execute those instructions, so that can be found by many ways. So one is direct ways. CPU time is equal to CPU clock cycles for a program into clock cycle times. In the problem, if they have given CPU clock cycles and clock cycle time, then we can easily find CPU time. Sometimes uh, clock cycle time may be missing, so alternative is CPU time is equal to CPU clock cycles for a program divided by clock rate. Clock rate is nothing but, so here you know, uh, and if you observe here, uh, time is nothing but 1 by clock rate. If I substitute clock cycle time here, then we will get CPU clock cycles for a program divided by clock rate. So this is marked as equation number 1. and this will be taken as a equation number 2. So depending on what data is given in the problem, we will use different formulas based on the problem. And so instruction count is nothing but number of instructions executed. For example, if there are 10 instructions in our program, then instruction count is 10. Okay, so instruction count is 10. Okay, if you know the number of clock cycles, and so CPI, that is clocks per instructions, so we can write it as CPU clock cycles for a program divided by instruction count. So CPI is nothing but how many clocks we need for executing per instruction. Okay, so that we will get by CPU clock cycles for a program divided by instruction count. Think that there are 10 instructions. Okay, so 10 instructions means instruction count is equal to 10. Okay, then CPU clock cycles for a program, think that it will take 20 clock cycles. Okay, then clocks per instruction is nothing but 20 divided by 10. Okay, 20 divided by 10. So that is equal to 2 clocks per instruction. Okay, so this is how we calculate clocks per instructions. When you execute or when you solve some problems, you will understand how to use these equations. Now time being, clocks per instruction is nothing but CPU clock cycles for a program divided by instruction count. Okay, and similarly clock cycles can also be defined as CPI into instruction count. Here IC is nothing but instruction count. If you see here, CPI and instruction count. Okay, and if you shift this instruction count to this side, so CPI into instruction count, so we'll get a CPU clock cycles. Okay, so substituting equation 3 in equation 1, if you observe, equation 1 is nothing but CPU clock cycles for a program into clock cycle time. Now CPU clock cycles for a program is nothing but this instruction count into cycles per instruction into clock cycle time. Okay, so we have four equations. One is CPU time is equal to CPU clock cycles for a program into clock cycle time, and if you replace this clock cycle time with clock rate, then you will get second equation. Then similarly, we can suppose instruction count is given in the problem and CPU clock cycles, we can easily find clocks per instruction, and based on this clocks per instruction, again we got a new formula, that is instruction count into clocks per instruction. By substituting this third equation in the first equation, we got instruction count into cycles per instruction into clock cycle time. So finally, CPU time is nothing but CPU clock cycles for a program into clock cycle time, that is nothing but clock cycles into cycle time divided by program. So usually if you see here, program consists of instructions. Instruction is measured in terms of clock cycles, and clock cycle is represented in terms of seconds, how many seconds a clock cycle will take. Finally, program is measured in seconds, how many seconds it will take to execute. Okay, so finally CPU time is measured in seconds. Okay, program consists of instructions consist of clock cycles. So instruction is usually measured in terms of clock cycles, how many clock cycles it is taking, and clock cycle again it is measured in terms of seconds. Finally program is measured in terms of seconds. Okay, so processor performance is dependent on three characteristics: instruction count, clock cycles per instruction, and clock cycle or clock rate. Okay, so these three characteristics are most important.